and then go over some of the things that set yassl apart from other SSL implementations. So yassl as a company was founded in 2004. It was birthed out of a need for a clean room SSL with a clear license, one that could be embedded into both commercial projects as well as open source projects. We're based in Bozeman, Montana, Portland, Oregon, and Seattle, Washington. Our focus is on open source embedded security, and we're used everywhere from cloud applications all the way down to small resource-constrained embedded devices. And our main products are our two SSL libraries, yassl and yassl. yassl is written in C++, where yassl is written in C, as well as the yassl embedded web server. So if you're wondering where Bozeman, Portland, and Seattle are, you can see they're in the northwestern part of the United States. Although our geographic coverage is pretty small, our products are used all over the world. These are some of our estimates for our product usage. So we think there's about 5 million units that have been distributed and used in commercial projects, and anywhere from 10 to 20 million in open source projects. And those numbers are growing every year. This last year we've had an especially good year. So what are some of the things that set yassl apart? These are 8 items. They're not all of the items, but some of the top ones that we consider. So the first one is standard support. We support all the current SSL and TLS standards, SSL 3.0, TLS 1, 1.1, and 1.2. And we'll continue to support the current standards as they come out in future years as well. We were one of the first implementations to support TLS 1.2, along with GNU TLS. The second item is memory usage. So yassl footprint size is anywhere from 30 to 100 kilobytes. Standard yassl build usually comes in around 60 kilobytes, and that will include a full TLS 1.2 client and server. And then if looking at RAM sizes, anywhere from 3 to 36 kilobytes of runtime memory. The library itself uses 3 kilobytes, and then on top of that you're going to have your input and output buffers, which defaults using small static buffers of 128 bytes. And then if you get an SSL record bigger than that, it'll go up to 16K per buffer by default. So that takes you up to the 36 kilobyte maximum there. And so because of our size, we have users anywhere from hobby projects running just a couple connections per server, all the way up to cloud services and load balancing environments who have anywhere from hundreds of thousands to millions of connections. And we've seen several of those in the last year too. The third point is our simple API. That's one of the things we really like to focus on is simplicity and ease of use. And so we've done our hardest from the beginning to keep things simple. Compared to OpenSSL, some of you probably know it can get kind of clunky and complex to use. And to support our simple API, we've also really enhanced our documentation in the last year. And so we came out with a yassl manual, yassl API reference, and then we also came out with an SSL tutorial, which should help people new to SSL or people wanting to know how to easily add that to their project. That should step them through it fairly easily. The fourth item is our OpenSSL compatibility layer. And so this contains about 300 of OpenSSL's most commonly used functions. And so this is kind of dual purpose. The first purpose is for people who are used to using OpenSSL. And so it'll be the same function names as they're used to using with that library. The second option, or second purpose, is for ease of porting. And so because you have the same functions, you can usually easily just replace OpenSSL with yassl. And it usually requires very little work, depending on the usage of OpenSSL. Fifth item is it's highly portable. And so out-of-the-box platform support, really we have a lot of platforms. You'll see in a few slides that we support by default. and those are anywhere from desktop and embedded environments, desktop and enterprise environments, all the way down to embedded operating systems. And then we also offer several abstraction layers, which have been built into yassl. One for OS, so to easily port it to your operating system. One for custom input-output, so if you want to run SSL over pretty much any transport medium that you would desire. For example, if you want to run it over Bluetooth, it'd be simple to do that. And then standard C library abstraction layer if you have a different C library you'd like to use with our SSL library. The next one is hardware optimizations. So about 3 years ago, I think we added support for Intel's AES-NI. And so that's AES hardware acceleration built into some of Intel's newer chips. And they claim it can provide speeds up to 3 to 10 times over just standard AES. So we have that currently, and then we have some assembly optimizations that you can take advantage of as well. And then if you have hardware crypto modules, we can pretty easily plug into your crypto hardware. It's kind of on a time-by-time basis right now, but that's one thing we want to work on in the future, is getting a more generic crypto abstraction layer developed. The seventh item is our license model, and so we're dual licensed under the GPL as well as a commercial license. So this provides an easy way to just download it, use it for free under the GPL version 2, and then seamlessly move into a commercial license if need be. We kind of followed the same path as MySQL, and so they use the same license model. And then we just added new support tiers this year, so people who are looking for commercial support can get that from us as well. And then the last point is the project's maturity. So many open source projects change hands throughout their lifetime, but we're proud to say that yassl still has the same developers on board that they did when we started in 2004. And so the vision has been consistent all the way from the beginning. We're on our 33rd release, I believe, and it's version 2.0.6. And it's been tested out in the open source community for the last 7 years, and so it's not brand new. There's been millions of people who have used it, and it's been used in pretty much everything, ranging from home automation to games to routers, cloud services, and lots of embedded devices. This is a list of ciphers that yassl supports. It supports pretty much all of your standard ciphers, including some stream ciphers, RC4, Rabbit, and HC128. And so the default stream cipher for SSL is ARC4 or RC4. And that's a pretty good one, but we decided it was getting a little bit old, so 3 years ago we introduced the Rabbit and HC128 stream ciphers from the eStream project, which some of you may have heard of, I'm not sure. But Rabbit is, I believe, about twice as fast as ARC4, and HC128 is about 5 times faster than RC4. This is a list of our currently supported operating systems, anywhere from running it on bare metal up to a wide variety here. And if you don't see the one you're looking for on that list, there's a very good chance it's planned future compatibility. So that kind of wraps up our section on what is yassl, how it stands apart from some of our other competitors, such as OpenSSL. And so now we'll move into part 2, which is what's happened in the last year with yassl. What kind of progress have we made? And we've done lots in the last year, both technical and in our community. So looking at some of the technical stuff that we've changed, we've added a couple new cipher suites. We've added ECC support to our library, as well as SHA-256. We have partnered with a company called Security Innovation, to bring the ntrue suites to yassl. And ntrue is similar to RSA, a public key method that it can provide you speed increases anywhere from 20 to 200 times faster than RSA, and that's depending on your key size. So it's less of an improvement when your key size is small, but as your key size increases, you're going to see more of an improvement over RSA. This is a graph down here showing the performance of initiating a new SSL connection. On the y-axis is the maximum asymmetric transactions per second, and on the x-axis is different libraries with combinations of public key algorithms. So you have OpenSSL with RSA at the far left, yassl with RSA in the middle, and then yassl with ntrue on the far right. We've added ephemeral Diffie-Hellman support for both client and server. We've added AES counter mode support, as well as SHA-256 certificate signatures. And so, regarding SHA-256, we've seen a few certificates showing up in the wild with SHA-256, but it's been kind of rare so far. But we see that growing in the future. So we've added this to kind of stay ahead of the curve and be kind of progressive, future-looking. We've added CTAC runtime library detection, and so this is a check to make sure that you're using the same public key options that you built the library with as when you are at runtime with the library. So say you build an application with normal math, and then when you're running it with the yassl shared library that is using fast math. This will provide a check to kind of let you acknowledge that inconsistency. We changed a few things regarding certificate processing. We added UID parsing for X509 certificates, and so UID will be contained in the subject field, I believe, and then you can use that through yassl, the yassl API. We added serial number retrieval, and we improved our CA certificate processing in several ways. You can now load multiple CA certificates per file, which can simplify your initialization of clients and servers, as well as a lot of things you port into are expecting a single file, and so if you need to load multiple CA certificates, it's helpful to have this. We have changed our root certificate verification. We used to require that all of the certs in the chain were loaded as trusted certificates in order to do verification. Now only the top or the root certificate needs to be trusted. And then now we check the CA basic constraint field of the X509 standard, which is just an extra security check. We've added better TLS 1.2 support through more comprehensive interoperability testing. We've supported TLS for about 22 months now, I think. And so we think we have one of the best and most tested implementations of that available today. We have improved our PKCS support. We added PKCS number 8 private key encryption support, supporting versions 1 and 2 of PKCS number 5, as well as PKCS number 12. We added password-based key derivation function 2, which previously we only had the first one of those functions. And then we also added the password-based key derivation function from PKCS number 12. We made a few changes to our package design. As far as headers, we simplified our header structure. So we used to install yassl under user local yassl, which made it for a simpler usage, but sometimes more complex when you're building with a program or application. So now we've moved it to a more standard installation location of user local, but it changes how you need to use it a little bit. So you should be aware of that if you're going to upgrade to yassl versions above 2.0.2. We have changed our makefile usage. We used to use recursive makefiles, one for each directory, and now we use a single makefile, which is simpler and faster. And yassl now uses compiler visibility, if it's supported, to explicitly expose or hide non-static functions. So this can reduce the global namespace pollution as well as possible collisions. We've added make test support, which runs our test suite, our unit tests, and our ctop grip tests. We've made it a little bit more portable and customizable by adding dynamic memory runtime hooks. And so we've had a memory abstraction layer for quite some time that lets the user control dynamic memory, but now you can do it at runtime, which is kind of nice. The same thing with logging. For a while we've had support in while you're in debug mode to configure your own custom logging callbacks, and now you can do that at runtime as well. Regarding, this is our embedded web server. We put out a new release of our embedded web server in the last year, just with some bug fixes, feature enhancements, better documentation and examples. And this is one thing we want to concentrate on in the next year, is making more improvements to our web server. And then in regard to technical, in addition to technical stuff, we've done a lot of ports to new chips and software packages. yassl is now a build option in curl, and we ported yassl to the embed prototyping board, and so it's available for their cloud compiler, both the library as well as a client example. Both of those you can download off of the embed website. Memcache is a dynamic memory caching, memory object caching system used to alleviate server load when you're using dynamic web applications. And so we made a patch to enable yassl use in that, and we call that secure memcache. And that'll be released sometime, probably in the next couple months, I would say. We added some operating system support for FreeRTOS, Haiku, Freescale's MQX, and then you can run full yassl in the web server on your Apple TV now, if you want. We support LWIP, the lightweight TCP/IP stack, and we also support Microchip's PIC32 platform now. We support the Clone web application framework, and so yassl is a build option when you're building Clone. And Clone is a web application framework that is kind of unique in that it includes the server and an SDK for building dynamic or static web content, and it bundles it into a single binary after you build your website. We're in OpenSSH now as a build option. WPA supplicant is used for controlling network connections, and so that's going to be a config file option for yassl. Host APD is used for authentication of networks, and that will also be a config file option. These two will be coming in the next couple months, probably. PPPD and EAP TLS. So PPP is a point-to-point protocol for making a network connection over a serial link, and EAP TLS is a patched, extensive authentication protocol using TLS. And so previously you used OpenSSL, and now you will use yassl. We're in free Radius now, one of the most widely deployed Radius servers, and that's going to be a build option as well. yassl will do hashing as well as provide authentication through EAP TLS. We are now a crypto provider for MIT Kerberos, along with NSS, OpenSSL, and then MIT's built-in crypto. And so we just finished this up along with a port. We ported Kerberos over to Android, and the GSS API to Android, which were previously lacking for the Android platform. So that should help significantly in developers wanting to secure their Android applications.
Does that include PK-init?
No, it leaves that out, the Android.
I mean the CISL supporting Androids.
I think that our crypto provider doesn't currently support that, because that was one thing that heavily used OpenSSL, and so that's something that we'll have to go back and more extensively rewrite that to use the CYASL. You now have 3 options for using CYASL on Android. You can plug it in as a Java SSL provider. So this requires rebuilding the entire Android operating system and adding CYASL as one of those provider blue things at the bottom. And so when you use javax.net SSL package, you'll actually be using CYASL. This is just a diagram of the Android framework. So when you do that, you're modifying both the libraries section and the Android runtime section. The second option is to use our CYASL NDK package. So this is an Android NDK application that shows you how to both use CYASL in the NDK as well as provide a CTalker example application. And this is on GitHub, so you can go grab it off of, this is the URL. You can also find it on our blog and website. And then your third option is to just cross-compile CYASL for Android. So this is going to do pretty much the same thing as the NDK package, but we've seen smaller library sizes doing it this way. And then now looking at what we've done as far as our code repositories and community. We moved all our code to GitHub from SourceForge before. We were just really impressed with how slick it was to use. They had good UI. It was really easy to collaborate between people. And so now all of our stuff is on GitHub. We introduced some support forums. So if you have questions about SSL or CYASL, please feel free to go post to our support forums. We formed some new partnerships. We're in the ARM and Avnet embedded software store now. We're part of SkypeKit. Security innovation is bringing about the N-True Cypher suites. We're in the Intel Embedded Alliance now, and we're partnered with conlon Logic, which makes the clone web application framework. And so with that, that's pretty much all of our new news in the last year. We have a lot planned for the next year too. We brought 2 more people on board for this last year. So we've got more engineering and business resources to use. We always offer free support for open source projects. So if you're working on an open source project and you want to implement or add CYASL into it, we'll gladly support you. Or if you think CYASL should be in an open source project, feel free to give us a shout, and we'll try to help you as best as we can. Is there any questions about our products?
What about Tor? Have you tried to learn Tor with CYASL?
We have been asked that. One thing, we haven't really gone forward with that yet, just because we're not sure. Sometimes people use Tor for non-ethical uses. And so it's just a business decision that we haven't made yet. We want to be part of that.
I have 2 questions. Has anyone other than the company doing the NTA routing requested for their key scheme or not? Is it actually used somewhere?
I'm not exactly sure on the usage of it. It's kind of unique that you have to control both your client and server ends,
Right.
because most existing servers aren't going to support the N-True Cypher.
Yeah, that's why it's like. Do you know any users for this outside of demos?
I know that we haven't had it in our library for too long, and so we haven't personally gotten any users from our side. Security Innovation will offer licenses as well, and I can't speak to what their usage stats are, so I'm not sure.
Okay. And the other question is the ports you described. Do they mostly make use of the OpenSSL API thing? Basically, you just made sure that it compiles in the OpenSSL compatibility mode, or you actually ported it to a new provider or a new, you know?
Some of them are, it really varies. So most of them will use the OpenSSL compatibility layer, just because, you know, when it's already existing in there, it's a lot easier to just overlay our stuff on top of that.
Mm-hmm.
And it's a lot easier for projects to accept our patches. But like some examples, like the Kerberos crypto provider, that was written from the ground up using C yassl.
How big is the list of the applications that do open SSL that can be compiled with the C SSL in the compatibility mode?
That can be compiled?
Yeah.
How big
Roughly.
is the list of projects?
Yeah.
I don't know, probably 20 to 30 is what we've done.
Okay.
There's a lot of projects we haven't tried, so I can't really speak to it until we try it.
But has it happened that it just works the first time you try? Or it needs tweaking?
Sometimes it works, sometimes there's like 2 or 3 functions that are missing
Hashing,
from our
like.
layer. But we usually just add those to our compatibility layer when we encounter that.
Have you had any failures to try to port something but it was too much work?
Not really. If it's too much work, we'll usually just try to reschedule it to when we have a larger block of time available, because it'll take our dev team longer to rewrite those functions and add that to our compatibility layer. So no, we don't fail. We just it just takes longer to add support.
If I have an OpenSSL application which uses hardware engines, would that be portable to yassl?
We would have to look at it. Like I said, we don't have our crypto abstraction layer in place yet, so it's not going to be an easy replacement. You're not just going to be able to plop it down and get going right off the ground. It'll take a little bit of work, but it shouldn't be too hard.
The meaningfulness of this is, I think, questionable.
The meaningfulness
Of using the OpenSSL engine thing.
Oh,
It's not the best interface for this.
using the OpenSSL
That's
engine?
my
Or
personal
the
opinion.
OpenSSL interface is never the best interface.
Right.
Yeah. You could say so.
I guess following on, do you have a similar abstraction layer for hardware tokens? So we can write modules for so how?
We don't currently have that. We can definitely look into it. We're always game for looking into things we don't have yet.
So what we could do is connect and then follow up with them, have a better understanding of where your needs are, because everything's kind of a priority, right? You have all these priorities you want to evolve in your roadmap, and it's constantly moving. So you can talk about where your needs are, where your priorities are, and see where it takes us.
Thank you.
Yeah, good job.
We also brought with us a bunch of yassl stickers if you want a sticker. I'll leave them up here.